Right, I want to explain about this new design. Um, right, my new rotors, or rather I call them the drums. Basically we have magnets arranged sort of like this. Right. I'm not going to draw the whole drum because there's no point. So what we have is we have a south field here, we have another south field here, then we have a north field, and then another north field. Now what happens with this arrangement is that these two south fields create a bubble, a large extension of flux. Normally we have a flux line. Now the best way to demonstrate it is to do it around this north here, because we have the flux lines coming around. Well, because they're close to the south field at this point, they tend to fold back in on themselves. So the flux lines are compressed, so we have a dip. So the flux lines basically are being drawn inwards at this point. Right? So in order to overcome that problem, and because of this, we have to have a smaller air gap. We have to have our collection coils, if you like, much closer in order to harvest that energy, because the flux lines are much more compact. Now, because the south fields are in opposition or equal opposite, well, they're actually both south, so they're actually deflecting each other's fields. What we end up having is a much larger extension of the field which comes out. Right, so the field, and the same goes with the north over here, so we have a much larger field coming out. Whereas at this point here, it's more condensed and it's collapsed. Now, what are the advantages of this arrangement? Well, obviously the arrangement is the fact that normally the drag effect or the lens effect occurs mostly between the south and the north junctions, where the field is changing from south to north. So what we actually have instead is we have a big gap, so that there's less drag on the system, because the changeover is so great. I mean, the distance basically is 12 millimeters here. Right, we've got 12 millimeter air gap between this point here, right, and the actual magnets themselves. So that is a huge advantage. Now, another thing to do is to use triacs, so that we only take energy from the peak waveform from the top. We just clip the energy from the top of the waveforms, which will have the least amount of drag on the system, because it will not basically, you can't really slow it down much, because it's such a greater distance. It has a job really to, by the time that this north here has passed, the flux lines have basically collapsed to virtually insignificant amounts. So the drag on slowing the system down is negligible. So what we do is we use a triac system. So the triac is basically, oh God, I'm trying to remember how to draw this now. But basically it's like two diodes. Right. Now, I'm probably drawing this all wrong. But anyway, you can look it up online. But triac basically what we do is we switch the triac on. We use trimmers on the gate. So we have the gate. Oh, I forgot where that is. I think it comes out here. So if I can draw it right. So we have a gate, and we have two of these, and basically what we're doing is our collection coil is coupled to our coil, right, and that's our output. And what we do, well, we have two of these actually on each side of the coil, on the AC coil. We adjust a control pot on the trimmer. I'm not going to draw the diagram. You can work it out yourself. But what we do is the waveform on my new device, on this new generator, is, so I'll show you. I've got my gauge on the back now. This look at the air gap in there. Let's get my torch. It's a bit hard to see. Right, there's my coil. The air gap there is 12 millimeters, and we've got ferrite cores in there. And because of the arrangement of these cylinders, is basically one cylinder south is facing upwards, and the next cylinder next to it is north facing upwards. I think I'll best have to just turn this over a bit. But right, I don't know if you can see that very well. Probably not. Anyway, we've got basically a south cylinder, a north cylinder, and a south cylinder. So because of that, we have a circuit. We have a flux and magnetic circuit. Now, as I turn the drum, there is very, very little cogging. Very little, until it stops. You'll notice that it's hard to make its mind up where to go, because it kind of bounces around a bit. It doesn't really cog. So it kind of bounces. My magnetic gauge is between the two concentrics on the top end. Look how much flux we've got there. That's a huge amount of flux. Now, this is on the back end of my coils, right? So we have a huge amount of flux coming through here, switching through, which is why this is generating so much more power. We see it's flipping my gauge really easily. And I couldn't get that to work on a previous build with that gap like that. I mean, we have a much better circuit of flux flowing through the system. So what we have with the waveform is we don't want to harvest the energy from the rise time or the fall time. So we have the rise time, and because we have two south magnets basically pushing against each other, what that does is it gives as an extended peak before the fall time, right? And we have an extended peak on the negative cycle before the rise time. So we have effectively got a longer duration of peak where we can take energy from. So what we want to do is use the triac basically to clip into the harvest the energy somewhere around like here and turn off somewhere around about here, so that we're only taking energy from the peak waveform. The reason for that is we're only taking energy at top dead center. And because we're taking energy at top dead center, we have less impact on the drag, on the rotation of the system. So to example, let me just use my lighter as a way of explaining this. Right. So imagine this is our the point where we're taking our energy. Because we're at top dead center, we're actually pushing that in that direction. Right. When we're taking energy, we're not pushing it that way, and we're not pushing it that way. We're actually pushing that way. So we're actually top dead center. So this is where we're taking our energy at this point, so that we're not actually slowing the system down. So if this lighter was the rotor, we're not slowing it down, we're not accelerating it. We are just taking energy at top dead center, which is at the peak of the waveform, which is when we are top dead center. And then the next waveform, we basically take energy on the other fall time of the other polarization at about top dead center as well. And by doing so, we minimize the drag on the system and the load factors, And I've been testing this, and it works very well. You'll have to look at my other live streams that I'm doing tests on. I've only just hooked up my triac system. Actually, I need to build a circuit board for it, because I really need to build I need to build one triac system for each set of coils. They need to be independent, so that I can independently tune each set, so I can get more power out of it. So anyway, because the triacs basically are rated at 500 milliamps, and I don't want to be pushing more than 500 milliamps, or I don't want to risk blowing them up. So anyway, so if you get the idea, if we're taking only power at top dead center, then there's less chance of the system being slowed slowed down. Anyway, that's basically to summarize how this will work. And I'm using my concentric magnets, which are I'm using them on the back end, where there's magnets basically north-south going around. Well, as you can see, they are being switched. They are definitely being switched, because these magnets here are alternating as I turn the cylinder. And they do make a big difference when I put them on. So, yes, I'm just taking this on my old phone at the moment. I'm demonstrating this at slow speed, because these things at high speed you won't even see them move, or they probably won't move because of inertial forces. But anyway, that's it for now.